Hello everyone, this is Easy Math. In this video, we are going to do class 8 rational numbers exercise 1.3. Whole of this exercise is about properties of rational numbers. We have to verify all the properties, all the 6 properties for the given rational numbers. So for that, let us just recall the properties which we have done earlier. In detail, we have done, but anyway, just recall it now so that it will be easy for us to do the exercise sums. So, properties of rational numbers. There are 6 properties. What are they? If you can remember, quickly tell. Closure, commutative, associative, identity, inverse and distributive. Okay, what is closure? Closure means when you add two rational numbers, the sum of the two rational numbers, that is the answer, is also a rational number. A by B is one rational number, C by D is one rational number. When you add them, your answer is also a rational number. Same way, when you subtract two rational numbers, that is also a rational number. When you multiply two rational numbers, that product after multiplying, the answer you get is also a rational number. But when you divide two rational numbers, the answer is not always a rational number, because 0 is also a rational number. When you divide a number by 0, it is not possible. Division by 0 is not possible. That is why the division is not closed. That is, closure property is not true for division. It is true for addition, subtraction, multiplication. And commutative, what is commutative? Second one, when you change the order and add. That is, A by B is one rational number, C by D is one rational number. What are we doing on the right hand side? Second number has become the first number and first number has become the second number. Even if you change the order, the answer will not change. But this commutative property is not true for subtraction. If you change the order, first number has become second number becomes first number, you won't get the same answer. This is not true. With the examples we have seen in detail. If you want to recall the full property with examples, you can see the previous videos. Okay. Now for multiplication, it is, even if you change the order of multiplication, answer will not change. It is like 3 into 4 is same as 4 into 3. But division, if you change the order, the answers will change. And one more thing, all these things only we are going to check in the exercise sums, where we are getting both the sides equal, where we are getting both the sides not equal. That is why you're going to verify the properties for the given numbers. And what is associative? Associative is just like commutative only, but commutative is for two numbers, but associative is for three rational numbers. Okay, first we add first number, second number, then add with the third number. And on the right hand side, after equal to, right hand side is add second and third, then add with the first. That is, we are regrouping. The grouping is changed for three numbers, but still you will get the same answer. But it is not true for, as commutative is not true, associative is not true for subtraction. But what is true? It is associative is true for multiplication. However you multiply the numbers, the answer will not change. But it is not true for division, not equal to. If you change the order, if you change the order of the numbers, here we group first and second number, here we are dividing second number and third number first. When you change the order of the numbers, you won't get the same answer in division. And when you come to identity element of addition is 0. With whatever number you add 0, you get 0. So 0 is called the identity element of addition, and no identity for subtraction. 1 is the identity element of multiplication, because with whatever number you multiply by 1, whether it is a decimal number, fraction, rational number, positive or negative, big or small, any number you multiply by 1, we get same number. So 1 is called the identity element of multiplication, and there is no identity element for division. Then inverse means we have tried the negative. For the positive number, it is minus. If it is plus 6 by 7, the inverse inverse is minus 6. For plus 6 by 7, minus 6 by 7. For minus 6 by 7, plus 6 by 7. We have to change the sign to get the inverse of a number. And there is no inverse for subtraction, and there is no inverse for division. And multiplicative inverse means it is nothing but the reciprocal. That is, interchanging the numerator and the denominator is the reciprocal. That is the multiplicative inverse. And the last one is distributive property of multiplication over addition. It is A into B plus A into C. And second one, multiplication over subtraction. A into B minus A into C. So this is all about just recalling the properties. Now we'll go to the first sum. The first sum is verify the closure property for addition and multiplication for the rational numbers minus 5 by 7 and 8 by 9. So which is the property we have to verify? Verify means check. We have to check whether it is true or not. What property? Closure property. For the number, for operation addition and multiplication. For the numbers minus 5 by 7 and 8 by 9. So the given numbers are minus 5 by 7 and 8 by 9. We'll check the closure for addition. What is it? We have to add the given two numbers and check whether your answer is also a rational number. What is a rational number? It should be of the form P by Q, numerator and the denominator. They can be positive or negative, but only condition is the denominator should not be 0. That is only rational number. Now here this is 9. So to add, we need LCM. If the denominators are different, can we add them? No, we need LCM. So LCM for 7 and 9. Do they have a common factor to divide? No common factor. Both don't come in same table. So multiply them to find the LCM, which is 63. So next step, you can tell me now, because we have become very much familiar with after solving so many exercises in rational numbers, you must have become very familiar with LCM simplifications. Now next step, 7 into what is 63? 7 nines are. Multiply numerator also by 9. But this minus sign as it is. 5 nines are 45. Plus 9 into what is 63? 9 sevens are. So numerator also multiplied by 7. 8 sevens are 56. Now signs are different. Subtract and put the sign of the greater number. From the greater number, subtract the smaller number. 6 minus 5 is 1. 5 minus 4 is 1. And sign of the greater number plus. So it becomes 11 by 63. Now what do you say about 11 by 63? Is it a rational number? Yes, it is of the form P by Q. We have a numerator, we have a denominator, and the denominator is not 0. So it is a rational number. Therefore, when you add two rational numbers, we get a rational number. Now we'll check the same closure property for multiplication. What is it? We have to multiply the given numbers. To multiply. What about the denominators? Do you want the denominators to be same for multiplication? No, not necessary. The denominators can be same or different and still the rational numbers can be multiplied. There is no need of LCM here. So what is the next step in multiplication? We have to cancel a numerator with the denominator if there is a common factor. Now check for the common factors. 5 and 7. No common factor, both are prime numbers. 8 and 9, no common factors. 8 is even number, 9 is odd. This is divisible by 2 and 4. This is divisible by 3, but no common factors. So if we check cross, 5 and 9, no common factor. 8 and 7, no common factor. So what to do? We have to multiply both the numerators and multiply both the denominators. Before you multiply the numbers, we need to multiply the signs. Minus into plus, or there is only one negative sign. So answer is minus. 5 8s are 40, 7 9s are 63. Now, is it a rational number? Yes, it is of the form P by Q. And they are integers. If you have negative numbers, you can have negative numbers also in rational numbers. Because numerator and denominator they are integers. Only thing is, the denominator should not be 0. So, which is not 0. When you multiply two rational numbers, we get a rational number. So, the closure property is true for addition and multiplication. Now, second question is verify the commutative property for addition and multiplication for the rational numbers minus 10 by 11 and minus 8 by 33. So, which is the property? Commutative, which is the second property. What is the commutative property means what? We'll recall once again. Commutative for addition, A by B plus C by D. If you add two numbers, that is even if you change the order and add, the answer will not change. For addition and for multiplication also it will not change. It is true for addition and multiplication, but not true for subtraction and division. Not equal to. Equal to for multiplication and addition. So let us change the order and check whether we are getting the same answer. So the numbers are minus 10 by 11 and minus 8 by 33. We are going to check commutative for addition. That means add both the given numbers, minus 10 by 11 plus minus 8 by 33. And what is the other side? We have to change the order. The second number becomes the first number and the first number becomes the second number. Just to avoid the confusion, or to make it clear, if two signs come together, you put on a bracket so that it is very clear for us, the sign and the operation and the sign of the number. So we'll take LHS. What is LHS? Left hand side. We'll simplify side by first. We'll simplify left hand side, then we'll simplify right hand side and check the answers. Okay, so write the left hand side as it is. It is minus 10 by 11, and whenever there are two signs, we have to change it into one sign. How to change? By multiplying. Bracket means multiplication. Plus into minus, minus. That is, write it at the center. And 8 by 33. Now for addition and subtraction, we need common denominator. Do you have a common denominator? No, the denominators are different. So what to do? Find LCM. 11 and 33 both come in very simple. Two tables, 5, 10 and 11 tables are the easiest tables by 11. So 11 ones are 11, 11 threes are 33. Multiply them. 11 threes are 33. So 33 is the LCM. Again, the same procedure of LCM. 11 into what is 33? 11 threes are. So multiply numerator also by 3. Minus 3 tens are 30. Minus 33 into what is 33? 1 time. Multiply numerator also by 1. 8 ones are 8. Now, rule of integers. Signs are same. Add and put the common sign. What is it? When you add them, 38. Common sign is minus 38 by 33. That's all. LHS is over. Now let us move on to RHS. What is RHS? The numbers are their order is changed. Minus 8 by 33 plus minus 10 by 11. Let us multiply the two signs. Plus into minus. Plus into minus is minus. We'll have minus in the center, 10 by 11. Now what happens? Again, it is subtraction, addition and subtraction. We need LCM. So let us find LCM 33 and 11. Previous LHS, we found LCM for 11 and 33. Now we'll see for 33 and 11, whatever it is. 11 is the common factor. 11 threes are, 11 ones are. So LCM, 11 threes are 33. So same LCM. 33 into what? 1. 8 into 1 minus 8. 11 into 3. So 10 into 3. Sign minus sign 30. Now signs are same. Add and put the common sign. Minus 38 by 33. Check LHS. Minus 38 by 33. RHS. Minus 38 by 33. Therefore, LHS is equal to RHS. What does it mean? Commutative property is true for addition. Now we'll check for multiplication. Okay, same numbers we are going to check for multiplication now. Let us take the LHS. See, minus 10 by 11 into minus 8 by 33 is equal to, change the order. Second number has become the first number and first number has become the second number. Let us take the LHS. Minus 10 by 11 into minus 8 by 33. Do you need LCM? No. For multiplication and division, LCM is not necessary. So we just, if possible, we cancel them. 10 and 11, no common factor. 8 and 33, no common factor. 8 and 11, no common factor. 10 and 33 also no common factor. So what do? Multiply both the numerators and multiply both the denominators. First multiply the signs. Minus into minus. Plus 10 8s are 80 by 11 into 33. Let's multiply. What is 11 into 33? 11 into 33. 3 ones are 3, 3 ones are 3. Below first number, 0 in second step. 3 ones are 3 and 3 ones are 3. Add them. 3, 6, 3. So it is 363. 80 by 363 is the LHS. Now let us check right hand side and see what answer we are getting. So right hand side, I have changed the order. Now see whether you have any common factor. 8 and 33, no common factor. 10 and 11, nothing. 8 and 11, it is even number, odd number. This comes in 2 tables, 4 tables, but 11 is a prime number. 10 and 33, it is in 2 and 5, but this is in 3 and 11. Can you cancel 11 and 33? Both come in 11 tables, or 8 and 10 in 2 tables? No. Even though they have a common factor, 2 numerators and 2 denominators, they cannot be cancelled. We can only multiply them. So multiply minus into minus plus. 8 tens are 80. And 11, here we multiply 11 with 33. Now it is 33 into 11. Let us check. 1 3s are 3, 1 3s are 3, 1 3s are 3, 1 3s are 3. So what is the answer we are getting? The same 363. So LHS is equal to RHS. Even if you change the order of multiplication, the answer is not changed. Therefore, left hand side is equal to right hand side. That means the commutative property is true for addition and multiplication. Okay, so the rest of the sums we'll see in the next video. Thank you for watching. Thank you all.